Start with problem 4.7 from the textbook. The inside diameters of bearings used in an aircraft landing gear assembly are known to have a standard deviation of sigma equal to 0.002 centimeters. A random sample of 15 bearings has an average inside diameter of 8.2535 centimeters. Now, part A says test the hypothesis that the mean inside bearing's diameter is 8.25 centimeter. Use a two-sided alternative and alpha is equal to 0.05. Part B, find the p-value for this test. Part C, construct a 95 two-sided confidence interval on the mean bearing diameter. So first, let's digest the question. First of all, it says that we have an standard deviation. So the standard deviation is known of the population. So sigma is known. And we have a random sample of n equals 15. So this is n. Okay? So now we start with first state the hypothesis. The null hypothesis is mu is equal to hypothesized value, which is 8.25. And the alternative mu is not equal to 8.25 since it told me that it needs to use a two-sided alternative. Number two, state appropriate test statistic. Since the standard deviation of the population is known, so the appropriate test statistic is Z naught equals to X bar minus mu naught divided by sigma divided by square root of n. So therefore, X bar is given, it is 8.2535 minus hypothesized value is 8.25 divided by standard deviation of the population 0.002 divided by the square root of n. Okay, this is equal to 6.777. Since we are using the table, so we approximate it to 6.78. Okay, now step number 3 is based on alpha. Alpha is given is 0.025. We identify the critical values and the acceptance and rejection region. So this is, let me draw a sketch here. So here we have this is in the middle, the acceptance region. This is my acceptance region. This is 0.95. And this is my So again, my acceptance region is in the middle, my rejection region to the right and the left. And here we have 0.95. So this is alpha over 2. This is 0.025. And this is 0.025. So my test statistic or my critical values are Z alpha over 2, which is Z.025, which is equal to 1.96. This we can get from the tables. And minus Z alpha over 2, which is Z minus Z 0.025 by symmetry. This is equal to minus 1.96. Now, since our test statistic is equal to 6.78, it falls in the far in the rejection region here. You can simply say it is here. Okay, just to illustrate. So now, continue. Since the Z naught, which is my test statistic, falls in the rejection region, we reject each node and conclude that the mean inside diameter, bearing diameters, is not equal to 8.25. Okay, so with this, we're done with part A. We find the p-value for this test. Again, let's do a quick sketch here, small here. We can use the same sketch, but I'm just going to repeat it. So this is my standard normal distribution. This is z equals to 0. This is my critical value 1.96. This is my other critical value minus 1.96. And the test statistic, we got it 6.78. So the 6.78, it's basically falls here. This is, let's say this is 6.78. Now for the p-value, basically I want this area to the right. Okay, now we know from the tables that and the standard normal distribution that the area to the right here it will be approximately equal to 0. Okay, now of course what we are finding here is the p-value divided by 2, but since it is equal to 0, it doesn't matter. So therefore, we can say for part B that the p-value is equal to 0. So now to construct this new part C as well, to construct the 95 two-sided confidence interval on the mean bearing diameter, since again the standard deviation is known, so basically we have this mu is between x bar plus z alpha over 2 sigma divided by square root of n, and from the other side we have x bar minus z alpha divided by 2 square root of sigma divided by square root of n. So now we have x bar is 8.25. T5 plus 1.96 times sigma is 0.002 divided by square root of 15, and from the other side it is 8.2535 minus 1.96, 0.002 divided by square root of 15. Okay, just plug in and you can write the values. I'll leave that for you guys.